Remember when we had a chip shortage? Oh, I remember. But in case you don't remember, I'm here to remind you. And we're not talking about these kinds of chips. Yeah, that's good. These are Pringles, by the way. I'm not sponsored by Pringles, but if they're interested, get in touch. We're going to be talking about computer chips actually. If you don't remember, we did have a shortage of those a while ago, and I'm here to talk to you today about why we did. And first of all, I'm Alex, and I'm no economist, but I'm also not a hardware engineer or an electrical engineer or a software engineer for that matter. So, anything I say on this topic should be taken with a massive grain of salt. So, this is actually an idea that my girlfriend gave me for this video, and she actually asked me why there was a chip shortage. And I went on a long rant on Messenger chat explaining something about logistics and supply chains and complex supply chain management, so much so that I thought it would make a good video. So, also, one more thing. Should have done that at the start of this video. Yeah, Christmas is coming. Need to have our Christmas hat on. So, since this is an idea that my girlfriend gave me, actually asked me this question, and since I went on a long messenger tirade about logistics supply chains, I thought it would make a good video actually, a good topic for a video. So this one is dedicated to my girlfriend, who's also my princess and my inspiration and muse. And she heard someone say that it was an issue of raw materials. No, not exactly. The chips are actually produced from silica, which is one of the most abundant chemical elements on Earth. It's probably 59% or something like that of the Earth's crust by mass. Even though the silica that's used for chip manufacturing is actually obtained from quartz crystals, but silica is actually probably one of the most common and most abundant chemical elements on the planet, and sand is basically silica. So it's not an issue of raw materials so much as it is an issue of a few other things. And one person that I'm personally going to point the finger of blame at, that person, his name is Dr. Michio Kaku. No, actually, I have nothing against the man. This is joking. I think he's a great physicist, a great presenter. But back in the early 2000s, when the Discovery Channel was still making good documentaries, one of those documentary series was Physics of the Future, hosted by Dr. Michio Kaku. And I've watched a lot of those documentaries, and I think I may have read at least one of Dr. Michio Kaku's books, but I can't be sure of that right now. And one of the things, in one of the episodes in those series, one of the things he said was that in the future, microchips would become so abundant, so easy to manufacture, so mass produced, so readily available, in fact, that it wouldn't really make sense to not put the chips in somewhere. So basically, one of the things he said is that even paper would have chips built into it. Fast forward to the early 2020s, a lot of the predictions that were made in those Physics of the Future documentaries back in the early 2000s, where the future was going to be so bright, like that Offspring song. A lot of those predictions did come true, even though we don't have as much lasers or flying cars, and we're not on the moon or Mars. A lot of other predictions did come through. We live in a much more connected and much more online and technologically advanced society now than we did in the 2000s, even though we don't have the flying cars yet and we're not at the moon. But still, give us credit. We've made a lot of technological progress. And even though chips aren't in paper as much, they're in a lot of other stuff. They're in this, During this actually, this probably has more computing and processing power than the PC tower I used for gaming back in back in the 2010s, 15 years ago, when I could barely run StarCraft 2, and the lag with Dota 1 was terrible actually. But this right now has more computing and processing power than that gaming machine I used back then, and that's a result of a few technological progress processes, one of which known as miniaturization. You may remember, I don't know if you do, that back in the day, chips would be these black prismatic box-shaped things that a few of those could fit in the palm of your hand, and they had output pins, something like an even number of pins, 4, 8, 16, 32, etc. And that black box contained in it a number of individual separate logic circuits or integrated circuits. That's another name for chips also, integrated circuits. And during the years and the decades, these integrated circuits, we've been able to make them smaller and smaller and package more and more of them into a smaller and smaller package. If that had not occurred, your mobile phones, instead of looking like this essentially, would have still been the size and shape of those Motorola brick phones that you have to hold like this when you talk, because it literally takes all of this space. It's this big by this big by this big, yeah, something like that. You would carry around a brick to talk on and use as a mobile phone, and that's all it did, took and receive calls. Whereas today smartphones are essentially a computer in your pocket that's more powerful than desktop computers used to be not so long ago. And part of that is due to the process of miniaturization. And that's how we got the abundance and capabilities of chips. But one of the issues is that we've decided that we have to put chips in everything, and chips are in so much demand, and that's one of the parts and factors contributing to having a chip shortage, because you have to have a chip in everything, everywhere. There's basically probably not an analog device in the market that's left anymore. Everything is digital. Everything has to be powered with a chip. Even though chips nowadays may not be small enough to fit through a syringe, still chips are abundant everywhere, including in things like washing machines and in your cars. I don't know if you know this, but automobiles have been nothing but rolling computers on wheels since at least the early 1980s. And even my parents' first automobile that's produced the same year I was born, that too had an onboard computer, an onboard CPU. So as for at least that long, automobiles have been just rolling computers on wheels. And I may not be a hardware engineer, but I did work for 6.5 years almost as a mechanical design engineer in the automotive industry. And the automotive industry is also a big driver and trendsetter in a lot of other industries that want to service the automotive industry. And also, the automotive industry is another big consumer of microchips. And imagine that an automobile has to have 100, let's say, number of chips in it, 100 different type of chips. That number may be even in the multiple thousands. I can't really tell you. I was just a dumb mechanical engineer, not a hardware, software, or electrical engineer or whatever. I just design mechanical parts. Anyway, so if the automotive industry is that hungry for chips, imagine how much other industries are hungry for chips. And there's also one other factor contributing to the shortage of chips, and that's streamlined, just-in-time supply chains, optimized. That means that if you have to produce an automobile today, if you have 100 automobiles that have to roll off the assembly line today, all of the components that you have to put in one automobile have to be available today before they're assembled onto the automobile that's ready to be rolled off the assembly line. Because building up large stocks of inventory is actually expensive. According to Lean and Six Sigma principles, inventory is considered one of the 7 deadly wastes. And the automotive industry, particularly, is one of the trendsetters in a lot of so-called best practices in a lot of other industries, among which are Lean principles and Six Sigma principles. So the automotive industry has been responsible for pioneering a lot of the best practices in those regards in a lot of industries. So, 2 factors: chips having to be everywhere, and overly optimized, streamlined, just-in-time supply chains that have zero slack. Because if you want to build a warehouse to store your inventory for everything that you want to put in your own production, let's say you build a specific type of widget and you need a specific type of sprocket for it, and you have an annual production plan, you're going to have to build 1,000,000 digits over the year. You don't just buy 1,000,000 sprockets in December of last year, just have them on hand over the year as you assemble the widgets that you're going to sell over the next year, because that's expensive. Building a large warehouse costs real estate expenses, costs building materials expenses, construction work expenses, etc. And having that cost on the books amortizes, and it actually affects the bottom line and the price of the product that you have to sell. So not keeping a large inventory of your supplies and also of the stuff that you build and sell makes sense. But that makes sense in an overly optimized and streamlined world where nothing ever goes wrong when you don't have any slack capacity. But what happens when something like a war or a big global pandemic happens? Well then, overly optimized systems that have very little slack capacity tend to fail. And suddenly, if you have 100 chips that have to go into one automobile to be assembled and rolled off the assembly line, and for some reason along the supply chain somewhere you have difficulties delivering 5 of those chips or even 1 of those chips, then you can't finish the automobile and it's sitting on the assembly line unfinished. And imagine that that's not just you, that's also the chip supplier that also probably has some supplier issues or delivery issues or logistic issues or whatever. Imagine if one of your chip suppliers has one of their own suppliers for whatever goods that they deliver locked down, that they can't work or their workers can't leave their homes or whatever, and your supplier can't produce the stuff that they need to sell you, they can't fill the orders towards you, and you can't fill your own orders. And that's the essence, in fact, of the chip shortage, and the example of how small pebbles can turn over the cart: overly optimized supply chains with very little slack capacity, and having an overabundance and over-reliance of chips and having to put them everywhere, and the perfect storm of a once in a lifetime or once in a century pandemic, and also followed by a war afterwards. And it's like a little bit like with the LEDs. I once interviewed an energy expert, and he mentioned something about light-emitting diodes. How look at this thing, the LED. It's a light, and it's very efficient, energy efficient, consumes very little power. Think about how much energy we're going to save on lighting by using LEDs. And now let's put LEDs everywhere. And LEDs end up using more energy than they were supposed to save. And that's also something that happens to the chips. They are going to make our lives so easy, so connected, so accessible, and we are going to produce them so cheaply and readily available. Why not put them everywhere? And now we can't satiate our hunger for chips. That's what happened. And when we can't satiate our hunger for chips, when we can barely satiate our hunger for chips normally, imagine what happens in a supply crunch as a result of a global pandemic, a war, and when we've already overextended our overly optimized and streamlined and just-in-time supply chains. Anyway, that's all I had for this video. If you liked it, give it a thumbs up. Drop me a comment below telling me how I really don't get it, and the cause of the chip shortage is because of all the chips that they had to put in all of the COVID vaccines or whatever. I don't believe those conspiracy theories. Subscribe to the channel for future content, and if you're feeling particularly generous, there's ways to support the channel. Links will be in the description below. So that's all I had. Till next time. I've been Alex. I've not been an economist, nor have I been a hardware engineer. Till next time.